Hello everyone, welcome to my channel. In this lecture, we will discuss about the production of formaldehyde from methanol. So formaldehyde can be produced from the oxidation of methanol. It can also be produced from the dehydrogenation of methanol. In this lecture, we will discuss about the production of formaldehyde from the oxidation of methanol. So first of all, we will open the Aspen HYSYS and we will go to the component list. Click on add and add the component. So there are component methanol, water, nitrogen, oxygen, hydrogen and formaldehyde. Now select fluid package, click on add and add the fluid package. I will select SRK as a fluid package. Now click on reaction and add reaction. Click on add, click on add reaction and click on add heterogeneous catalytic reaction. So heterogeneous catalytic reaction will take place inside the PFR reactor and it will become PBR reactor, peg bed reactor. Click on add reaction. Now click on reaction number 1. Add the component. So methanol react with oxygen and it produce formaldehyde and water. The stoichiometric coefficient for methanol is -1, for oxygen -0.5, for formaldehyde 1 and for water also 1. Basis is molar concentration, but I am selecting partial pressure because this reaction takes place in gaseous phase. The base component is methanol and the phase of reaction is vapor phase. The minimum temperature and maximum temperature are given. The base unit is in kilopascal. Now click on reaction rates. These are the free exponential factor. So I am assuming some free exponential factor. E is activation energy. So I'll also assume some activation energy and beta. So suppose beta is 0. Reverse reaction. So there is no reverse reaction. It is a forward reactions. So these will be 0. Now attach the reaction to fluid package and click on add to fluid package. Go to the simulation and add the unit of rations. So first of all we will add pump, add compressor, heat exchanger, another mixer, another heater, and this is the second. So add pump, compressor, heater number 1, heater 2, mixer number 1, and go to reactor and add the PFR, plug flow reactor. Drag and drop it and add heat exchanger. So cooler. I will select cooler is. Now go to the separator and add the absorption column. Drag and drop it. This is the absorption column and add distillation column. Now add material stream. So the inlet to pump is methanol and its outlet is pump out. Pump energy is suppose PE that will then pass through heater. So this is heater inlet, heater 1 outlet and heater 1 energy. Now click on compressor and add inlet is air. This is the compressor outlet. Compressor energy. The outlet from compressor will go to heater. So this is compressor outlet. This is heater 2 outlet and this is heater number 2 energy. Now heater 1 outlet and heater 2 outlet will combine in a mixer and it will produce the mixer 2 outlet. This mixer 2 outlet will pass through a plug flow reactor. So mixer 2 outlet and this is the reactor outlet. There is no pressure drop inside the PFR reactor and click on reaction and detail. These are the rating. So length of reactor is 0.8 meter and its dia is 0.1 meter. Number of tube is 1 and the void fraction. So there is some catalyst inside the PFR reactor. Therefore, it will become a fake bed reactor. So the void fraction of catalyst is 0.4. Now close this one. The reactor outlet will pass through a cooler. This is the reactor outlet and this is outlet and this is the cooler energy. This cooler outlet will pass through the bottom of absorption column. So from the top, water will entering from the top and the cooler outlet will enter to the column at the bottom. So go to the flow sheet and go to model and stream and add stream for water. So double click on stream number 1. The stream is water. So stream name is water. Water is entering at 30 degree centigrade and 138 kilopascal and its molar flow rate is 200 kilogram mole per hour and its composition, this is pure water, so its mole fraction will be 1. There are no other components, so their mole fraction will be set as 0. Double click on the absorber and water is entering from top. From the bottom, the cooler outlet will entering. There are 20 number of stages in the absorption column, and the absorber top product will be T1. Bottom product will be bottom 1. Click on next and click on the top pressure. So the top pressure of the absorber is 150 kilopascal. Bottom pressure is also 150. Click on next. These are optional. Click on done. It is unconverged because we have not specified other stream. So close this one and double click on distillation column. So entering stream of distillation column is B1. There are 10 number of stages and the condenser duty is QC, the reboiler duty is QR. There is partial condenser and the top of the distillation column is B2, bottom is B2. The overhead wafer will be the overhead wafer from distillation column. The feed is entering at stage number 5 to the column. Click on next. This is once through reboiler. Reboiler can be in circulation reboiler without vapor. It can be circulation reboiler with vapor. But I am using once through reboiler. Click on next. The top pressure of the distillation column is 1.3 bar. And the bottom pressure is 150 kilopascal. Click on next. These are optional. Click on next. The reflex ratio to the column. So I'm assuming reflex ratio 2. Click on done. It is also unconverged. So first of all, we will specify the stream. This is pure methanol. It is entering to a pump. So the temperature of methanol is 25 degree. It is entering at 1 atmospheric pressure, 1 atm, and its molar flow rate is suppose it is entering at the molar flow rate of methanol is 100 kilomole per hour. It is pure methanol. So its mole fraction will be 1. No other component, so their mole fraction will be 0. Click on OK and stream number 1 is specified. Now it passes through a pump and its pressure increases to 3 atm. 3 atm. After passing through pump, it will go to the heater and the heater outlet temperature is 150 degree centigrade. There is no pressure drop across the heater. So double click on heater and go to the design and parameter. The delta P is 0. Close this one. Now go to air stream and the air is entering to the compressor at 25 degree and 1 atmospheric pressure. We have no information about the molar flow rate. So we'll go to the composition and click on bases. Click on the mole basis and close this one. So we will assume 100 kilomole per hour nitrogen and 100 kilomole per hour oxygen. There are no methanol, no water, no hydrogen and no formaldehyde. Click on OK. The compressor will increase the pressure of the air to 300 kilopascal. After compression, the air will pass through second heater and its temperature will increase to 200 degrees centigrade, and its pressure will also changes. There is some pressure drop across the heater, so its pressure will be 265 kilopascal. After that, this mixed stream will go to the plug flow reactor. Double click on reactor and it shows that require a reaction set. So go to reaction and here add reaction. So it is added. Now the reactor outlet will pass through cooler. So the cooler outlet temperature is given. It is 100 degrees centigrade. 100 degrees centigrade and 1.5 bar, 50 kilopascal. Now this cooler outlet will pass through absorption column. Double click on absorption column and it is unconverged. Click on run. It will take some time to converge. So it is converged. Now the bottom product of the absorption column will enter into a distillation column. Double click on that column and click on run. So there is no enough information. Click on OK and go to monitor. So the reflux ratio is given. The distillate rate is not given to us, so we will assume some distillate rate 40 and the overhead vapor rate is suppose it is 40. Now it is converged. Close this one and double click on reactor outlet. Click on composition. So 0.1%, 0.1% formaldehyde. Now double click on the reactor and click on detail, view reaction and change these values. For exponential factor is suppose this one. I'm increasing the activation energy and there is suppose B value also. Suppose B value is 0. Now click on reactor outlet and check the composition. It is 28% formaldehyde is produced. So in this case 28% formaldehyde is produced. So it depends on the reaction detail. So when we increase this pre-exponential factor and activation energy, the rate of reaction inside the VFR reactor will increase. The conversion of methanol will increase when we changes these value. It also depends on the molar flow rate of the methanol and air stream. So suppose the molar flow rate of methanol is suppose 200 and check the composition of formaldehyde. So it is 40. Now click on this one, change this one to 150. It will take some time. So double click on this one and add the molar flow rate of methanol 100. Now check composition of formaldehyde. It is 28%. This is water. Change this one to 300 gram per hour and check the composition. 28. Double click on this one and increase it to 150. Now check the formaldehyde composition and here it is 35. Now I am further increase this to 170 kilogram per hour and check the composition. So 37%. 37% formaldehyde, which is a formalin solution. You can also check the absorber top product. Click on this one and here it is 39%. Click on the bottom of distillation and check. It is pure water. Click on the feed of distillation column. So it consists of formaldehyde and water. So here water is removed and click on the distillate of distillation column. Double click on it and it is pure water. Click on the wafer product of distillation column and here it is formaldehyde and water. So you can also recycle this stream to the pump to increase the production of formaldehyde.